Right, this is the second video for homework 3. The first video is done and is uploading as I speak. This is the second video, and this video shall be on quadratic graphs. We didn't really do much of this in in school because it involved drawing and it was a bit awkward to do. We kind of skipped this topic a bit, but we're going to try and do it as best we can through this medium. So let's have a look at the first question. Here is a graph of y equals x squared minus 2x minus 3. Write down the turning point of this graph. Okay, so the turning point is where the graph... So if I get the pen out... Is the pen going to work? There's the pen. Right, so as you see here, the graph is going down. So as the x value becomes bigger, the y value is getting smaller. But then it stops doing that. It stops doing that here. And then after this point, as the x value gets larger, so does the y value. It goes from having a negative gradient to a positive gradient. And the turning point is where it changes from having a positive gradient to a negative gradient. And we want to basically where the curve flattens, and we want to see where the curve flattens. So if I just get rid of that, we have a look at this point here. Do a little dot. We go across and we go up. We can see that the x value is 1, the y value is minus 4. So we do a 1 and we do a minus 4. Use the graph to find the roots of the equation. Okay, so if we rub off all of this stuff we've just done here, there we go, get rid of all that. The roots of the equation are where y equals 0. It's basically solving it. So if we go along this line is where y equals 0, because here is where y equals 2, y equals 4, y equals 6, and this line here is where y equals 0. So we're looking for the x values of when y equals 0. So if we go, so we want to see where this line intercepts our y equals 0 line. So we look here and we look here. And what is the value of x here? The x value here is 3. The x value here is negative 1. Because you see this is 0, this is minus 2, this is halfway between them, that's minus 1, and then the same for 2 and 4. So the roots are x equals 3, x equals minus 1. Right, okay, so that's fine. Let's go to the next question. Here is a graph of 2x plus 6 minus x squared. So they've changed the order around, but it's still a quadratic equation. Right, and the turning point, okay, so you can see here, it has a positive gradient, because as the x value gets larger, so does the y value, and then here it's negative, because as the x value gets larger, the y value gets smaller. We want to know where the turning point is, and the turning point is here. You just do a little cross, and that can kind of help you figure out the x value and the y value. So here we have 1, here we have 7. So we have 1 and 7. Find the roots, and I'm just going to make sure this is recording. It is recording, what a dream. Okay, so if I just get rid of the all this gubbins. So the roots, we want to find the x values when the y values are 0. So we want to see where it crosses this x-axis. So we have this point here, and we have this point here. Now this is a bit more tricky to work out, but if we just look at it and kind of go increments, so we have here is 3, and here we have minus 1. These little increments are going to represent 0.2, so we go 0.2, 0.4, 0.6. So we're going to have 3.6 and minus 1, minus 1.2, minus 1.4, minus 1.6, and minus 1.6. Perfect, let's go to the next question. And again, this question is just asking for the same thing. So where does it turn? We've got a negative gradient, we've got a positive gradient, we've got the turning point. We go up, this bit is a minus 1, this bit is a 6. So we have minus 1, 6. Use the graph to find the roots of the equation where e equals 2. Now this is a bit different. This isn't just asking you to find the roots when it equals 0. I want you to find it when it equals 2. So the line where it equals... So normally we find that line where it equals 2. 0, sorry. But this time we're actually looking for it when y equals 2. Because if you think about this equaling y, we've changed our value of y to 2. So y, which is this, is now going to be here. So if I just get rid of those lines. So we look across the y equals 2 line, we get our point being there, and we get our point being there. So if we go down, we see that's about minus 3.8. And this is 1.8. If you just count the little increments across, and then you go up to where it joins the line, you can see it's just behind the 2, it's 1.8. So we go to the next question. Complete the table of values for y equals 7x minus x squared. So, complete table of values. Minus 1, so we want 7 lots of minus 1 plus minus 1 squared. 7 times minus 1 is minus 7. Plus minus 1 squared is 1. Minus 7 plus 1 is minus 6. Now 0. 0 times 7 is 0. 0 squared is 0. 0 is minus 0 is 0. So this is just going to be a 0. Let's get rid of this thing here. Let's just make it a bit tidier. 1. 7 times 1 is 7. Minus 1 squared, which is 1. 7 minus 1 is 6. So this is going to become 6. In fact, I've got that first bit wrong, haven't I? That's not minus 6, because minus 1 times 7 is minus 7. Minus 1 squared. Minus 1 squared is 1. Minus 7 minus 1 is minus 8. So that's my bad. I'm sorry about that. So let's keep going through. 2 times 7 is 14. Minus 2 squared, which is 4. 14 minus 4 is 10. 3 times 7 is 21. 21 minus 3 squared, which is 9. 21 minus 9 is 12. 7 times 4 is 28. 28 minus 16, that is 12. You can do this written down just to see if you're getting the same answers. 7 times 5 is 35. 35 minus 5 squared. 5 squared is 25. 35 minus 25 is 10. So now it says on the grid, draw the graph for values of minus 1 to 5. So if we look at our minus 1, we have minus 8. So if we count minus 6, minus 7, minus 8, about here. 0 goes to 0, which is there. 1 goes to 6, which is about here. 2 goes to 10, which is there. 3 goes to 12, which is here. 4 goes to 12, which is there. And 5 goes to 10, which is here. So our graph follows this kind of trajectory. I'm going to try and draw it the best I can, although it's not going to be fantastic because I'm using my hand. Right, so when you draw your graph, make sure it goes through all the lines perfectly. You can kind of do it by you make sure you draw a continuous line that goes from the minus 1 bit all the way to the 5, and just make sure it goes through the points. My graph isn't going to be accurate, but you can basically see the gist of it. Use the graph to find an estimate for the turning point. So the turning point is going to be here. It's going to be this point here where it goes above and then comes down. So the turning point is going to be, well, did it want the turning point before in terms of both? Yeah, it wants coordinates. So the turning point is going to be about 3.5, halfway between this 3 and this 4. And then I would say about 13. Okay, now it says find the solutions to the equation 7x minus x squared equals 0. Okay, so we want numbers that multiply to get, so 7x minus x squared equals 0. We have our first one, which is here, because this is where it crosses the y equals 0 line. So we have 0, and if we take out x as a common factor for this, we get x brackets 7 minus x equals 0. We've taken our 0 out, we've equated that to 0, now we equate this to 0. 7 minus x equals 0, we add x to both sides, we get x equals 7. So we have 0 and we have 7, and those are our two solutions for this equation. Is this the last question for... No, oh, wait. Oh no, this was the last question. Was this the last question? Wait, if we go back to the very beginning. Yes, okay, that was the last question. Okay, so that is quadratic graphs done. There wasn't many questions. There wasn't many questions for that one. I hope it was easy enough to follow. If not, I can do it all over again. Thank you for watching, and I will see you next time.